Chapter 18, problem number 7. Water has a mass per mole of 18 grams per mole, and each water molecule, H2O, has 10 electrons. A. How many electrons are there in 5.72 liters of water, which 1 liter is equivalent to 1 times 10 to the negative 3 meters cubed? And B. What is the net charge of all these electrons? So for part A, they want you to find out how many electrons are in 5.72 liters of water. And they give you that 1 liter is equivalent to 1 times 10 to the negative 3 meters cubed. They also give you the mass per mole of water, and that each water molecule contains 10 electrons. So you would use N equals to 10 N times NA. So N represents the number of electrons. Lowercase n represents the number of moles in the water molecule. Na represents Avogadro's number. And this is given. So we're going to use N equals to 10 N times NA. So now we just break it down even more. So you're trying to find N. So 10 times lowercase n would equal to M over 18 grams per mole. This M represents the mass. And this is times Avogadro's number. So 10, break this down even more. P times V. This represents the density, and V represents the volume. So it's density of the water times the volume. That's what mass of the water is equal to. All over 8 grams per mole. times Avogadro's number. Okay. And we continue. 10 times 1,000 kilograms meters cubed times 5.72 times 10 to the negative 3 meters cubed times 1,000 grams over 1 kilogram over 18 grams per mole. And don't forget to multiply everything by 6.022 times 10 to the 23rd mole to the negative 1, or inverse mole. And this represents Avogadro's number. So you plug this into the calculator, and your answer would end up being 19.1 times 10 to the 26 electrons. So this is just answering part A, and you're going to need this for part B. So part B says, what is the net charge of all these electrons? So you calculated in part A that the number of electrons in a 5.72 liters of water is 19.1 times 10 to the 26 electrons. So now you have to find the net charge of all of these electrons, which just basically means that you're going to convert this amount of electrons to coulombs. And all you have to do is net charge, which is represented by uppercase Q, times 19.1 times 10 to the 26 times negative 1.60 times 10 to the negative 19 coulombs. And you have to make sure it's negative because you're dealing with electrons. If it was protons, it would be positive. So you end up getting the net charge, which equals to negative 30.6 times 10 to the 7th coulomb. And that will be the answer for the net charge of all these electrons, part B.